Hello, everyone. Thank you. I want to talk today about Glamorous Toolkit. Now, given that this is a gathering of people that are more inclined to look into small talk, I'll also start from the small talk, um, the small talk context in which Glamorous Toolkit was born and was implemented in, and then shift a little bit away from there. So the goal of the presentation is to provide an idea or attempt to describe what is Glamorous Toolkit, at least what is Glamorous Toolkit from our point of view, of the ones that they've created it. And so first, I am Tudor Gîrba. I'm a CEO. I'm the CEO of Think. At Think, we have kind of a single goal, which is to make the inside of software systems explainable. And Glamorous Toolkit is the vehicle that we've built, that we're using to actually achieve this goal. So to both find a way to how do we make effectively, how do we make it possible for people to make the systems explainable? And on the other hand, to actually solve actual problems that appear in industry. So we are funding ourselves as a consulting company, even if the pretty much all the results that you're seeing on the technical side, but also on all the research that we're doing on the method side, so around moldable development, they're all freely available. We get the funding by actually solving problems for our customers, and we typically solve the hardest problems. Most of the time we work with two kinds of situations, two kinds of engagements. On the one hand, we have crises related to legacy systems. People have built those systems for a while, typically try to change it in some way, and they find themselves in the impossibility of actually doing it in practice, and we actually help them to get unstuck. On the other side of the spectrum, because we are able to reason about systems typically faster than what happens today in industry, it means that it can also be transformed into a competitive advantage. So we actually work with companies that are willing to invest in these new abilities as a competitive advantage. But so Glamorous Toolkit is actually, it's not an academic exercise. It's really used in practice. And pretty much everything that exists there has been needed for some particular problem or some point of view. So in short, the way we describe what Glamorous Toolkit is we say it's a moldable development environment. Now, what is that? Well, here I have a bunch of objects displayed in their raw form. So typically just seeing variables and values. And I just display them here on the screen. And this is what most experiences boil down to when it comes to looking into a system. We look through some sort of rigid perspectives into the systems, and we basically do a lot of too many things in our heads. And as opposed to this, we are saying, well, instead of looking at systems through generic tools, what if we can build custom tools? So basically here we have the same objects, but now presented through views that only make sense for those objects. Now, why objects? Well, because objects are especially in the object-oriented system, objects are the smallest unit. So for the longest time, we started on this journey on moldable development about 15 years ago. So for the longest time, we spent on just trying to answer the question, how can we affect how we reason or relate ourselves to a single object? Now, why a single object? Because it's the smallest unit. And because Smalltalk has, systems or software has fractal-like properties, if you can fundamentally affect the smallest unit, you actually have a chance of affecting the largest pattern, so larger systems. So we spent we use the same environment, both for looking at the tiniest detail and also at the broadest details and everything in between. And so this is where that's the focus that we have in Glamorous Toolkit. Now, So when you say like how many of these, like what kind of, so each of these is a tool. So here we see a couple of dozens on the screen, but how many do we have? So in the Glamorous Toolkit, so here you're seeing a visualization of all the classes from Glamorous Toolkit organized in packages. And highlighted in blue, you see all the classes that have at least one custom view, inspector view in this case, associated to them. And in green are those that define some examples. What you're seeing here is that it's everywhere. This idea of custom tools are essentially needed throughout the whole system at any level of abstraction, and we are actually using them like this. We literally are building tools for every single development problem. So we're not building it for some problems. We don't just have a few kinds of tools. We have lots and lots and lots of tools, and we build more and more for every new problem that comes our way. Now, to describe, what Glamorous Toolkit is, I will stop presenting it, let's say, in a formal way. So this little slideshow here comes from Glamorous Toolkit, and what you're seeing here is one of the notebooks. It's called a Lepiter. So it's like a notebook, but it's also a knowledge management system at the same time. So here's the outline of the things that I want to show. And yeah, as I said, like Glamorous Toolkit is implemented in Smalltalk, and so particularly in Pharo. So we can take a look at it here. We can see I can have a snippet. So in this case, here I had a snippet with just an element embedded here with showing me the presentation that I had, or this. While here I'm now in. I have a snippet with Pharo code. So for example, I was talking here about views related to, so inspector views, so extensions to the inspector for different kinds of objects. And the question here is, how many are there? So what I have here is I have a little script which says, give me all the amounts of all the methods that are annotated with GTView. So if I look at one of these, I can see that this is a method in this class, and it's annotated with GTView. And the same with all of the other ones that exist here. And so now the question is, how many do we have? So I'm going to switch here. Instead of showing the default tool, I'm going to switch to the inspector, showing me this filter, because I basically have executing the snippet gives me a little object, which is a filter object, so kind of like a meta object that knows how to present itself with editors. In this case, this is a full editor here in the inspector. But it also gives me a metrics view. So what this one does is, because it's not computing everything, it's lazily computing only when it's needed. So you're basically seeing here the amounts of methods that are being detected to be annotated with GTView. So we're basically at 3,400 and so. This is not entirely the image that you're seeing here. The distribution is not only the distribution, but the distribution has more than 3,000 such extensions. And we're here talking just about the extensions to the inspector. Now, what's interesting here is that all of these extensions are little plugins. So you see, typically when people talk about the idea of extensible environments is not new. However, when you look at the amounts of things that people have, the amounts of extensions that people have, you will see that even if maybe worldwide you take the most popular development environment, for example, and you'll see that you'll have into tens of thousands of plugins. But in our case, we take it out of the box and there are a few thousands there. When we're going to work with the system, we're going to build more thousands of tools per system. So we're not talking about a global size measured in thousands or tens of thousands. We're talking about per system. So orders of magnitude more. Now, of course, this would only work if tools become much cheaper, much more organic. They can grow much more organically. We can't just go and have a lengthy process of building these tools. It needs to be much more fluid. And this is the difference. That is what the focus is in Glamorous. The primary focus in Glamorous Toolkit is. How do we make the process of creating these tools as seamlessly as possible and as seamlessly part of the development process as possible. So, for example, here you're seeing how many methods there are, and here we see the average lines of code, for example. So we are talking about really, really small tools that many of them are actually throwaway. So in this case, these are the reusable tools, but we have many more during the process of building, constructing or reasoning about software that we're actually just creating views that we're just going to use for a few minutes, and then we throw them away. So a whole different way of approaching. So that's the focus through which we are actually looking at Glamorous. And of course, it comes from there exists this the idea that it is implemented in a language and it works with some other language. So the question more is what is Glamorous Toolkit? And it's kind of reasonable to look at it as perhaps as a Smalltalk environment, given that it is implemented in Smalltalk, and given that Smalltalk is the first language that we are supporting because we needed the tools to build the environment itself. So what I have here in this outline here, so this is a page, and not just with snippets, but there are, for example, in this case, is a link. These are links, and these are links to other places. It could be in the same knowledge base that I have here, or to other knowledge bases that I have around. In this particular case, I just link directly to the book that comes with Glamorous Toolkit. So Glamorous Toolkit is also interestingly documented within itself quite extensively. So I link to this executable domain-driven design as the name of the page. And now if I maximize this, I find myself in the Glamorous Toolkit book, and I can see that it's reasonably extensive here. Now, I wanted to show you this. This was an interesting exercise that we went through, and someone joined Pink a while back, and so our team, and they started to implement just a simple game as an exercise. And this was the Ludo game. And so a Ludo game is one of these when you have some tokens and you have to move them around the board and bring them here at the end. And of course, these tokens can be captured along the way. So you can actually play this one. You can see here, role player A is to roll the die, and okay, player A can move, and so on. So I can actually execute this one here, but I'm in a book, in a notebook, and the question is, where does the code come from? And I can see here at the bottom, there's these examples. There's something called example, and I can go and browse what that is. And I can see here, and now I spawned something that we call a coder. So coder is, in Smalltalk, is a system browser. In other places, it's called a code browser, or so we call it coder. So it's a place where you actually get to see the structure and manipulate the structure of the code. So here, if I maximize this one, for example, okay, yeah, if I maximize this one, I find myself looking at all the packages from the image, and here I'm selected the method, and I can see I selected the class, and I can see this method over here. Now, this method it's called game showing all moves 3. And what I can see here is that there's an initialization over here, and then there's some assertions. So looks like a test, basically. But it's also annotated with something called example. And the difference between an example and a test is primarily that it is returning an object. So we are expressing tests basically through this example. So this is like a small difference. We'll say maybe it's just a difference in aesthetics or so. Well, there's kind of interesting side effects of expressing tests like this, because one of the things it means that I can, for example, here call another method, which in this case is also an example, and this will give me some object, and this example then becomes a setup. But in this case, because it's not a special It's not a special entity. It's just another example where I can have assertions. I can actually have assertions in my setup for every one of these examples. Now, of course, once we have these kinds of dependencies, so different examples, going from one another, I can actually take a look at all the graph of examples. So these are all the different kind of examples that I have in this particular class and how they depend on each other. Okay, but let's go back to our thing. So here we said, well, why do we return the object? Well, we return the object because we're thinking this. Well, what is the test? Well, the test is I get an object, I set it up, I ensure that it has these beautiful properties. And then in the typical testing scenario, we think that the best thing to do is throw it away. And I think, well, that's kind of like a waste. So why throw it away? Why not just give it a chance to survive? But of course, now in typical test-driven development flows, tests are interesting as long as they are red. That's when people look at them. As soon as the tests become green, poof, we're no longer looking at them because we're just happy that they are green. But we think, well, what if there's a conversation to be had after the test is green? And that's what this little tiny thing actually does. Now, if I'm now going to inspect the results, so you can see there have these extra buttons here in my method, and now I get an object. But this object is not just any object. It's an object that knows how to present itself. And all of a sudden, I can have conversations about this particular object, knowing that it has interesting properties. It's a tested object. And now I can have conversations with it, and I can actually start building on it. So, for example, I can go here, and I can say player A has to roll. I can go and I can do this. I can roll something, and I can move again a token. So this is something that I can just do, right? I had some things, and now I can play with some extra scenarios, which is pretty much what development is. I take the system and then I build on top of it. So it's one of those things. Now, of course, the other thing about this is that these views, once I have the views, I can also transform them into documentation. And that's exactly what I see here. You take an object, a view, and that becomes documentation. It's an interesting side effect. The effort is pretty much the same. So this is normal test-driven development. Because we're building the views while we develop, documentation is essentially just a side effect. It just grows. And it's tested by design. So, let's go back to our little story. When we first, in the first exercise, we said, well, what if we implement it just following test-driven development? So just normal, I write the code here, I implement whatever is needed, typically in the debugger, and I build some views at the end. So just normal test-driven development, which was nice when we got to this kind of situation. So for example, here, I can see I'm in here. I can see moves 2, I can see move 1. So I can do, for example, take a look at moves 1. That's the state. And after which, right, so D has now is on the thing, on the table now. And now I can execute moves 2, and I can see what happened. There was a small flicker there, and I can see the D basically move from here to here. It's kind of nice and it's interesting, but all of a sudden, if I do a few more of these, I now look at this. D now got here, A got here, A got here. It's a little harder to kind of imagine what happened there. Of course, if I squint here and I can kind of, run it in my head, I can kind of imagine what that is. But the thing is, I never want to imagine systems. I want the system to show itself. And the question is, what would be the most interesting way for the system to show itself? And the most interesting way here, we said, well, what if we see the actual move? That is, I see a token and I see from where to where it moves. Simple thing. But the thing is that because we implemented test-driven development, we didn't have, there was no concept of a move. We simply just had side effects over the system. So then we said, well, in order for me to draw something that makes it comfortable, I have to introduce this notion of a move. And that's basically what we see here. So if I now execute this again, and I take a look at the moves over here, and I can see here the list of those moves, right? So I can now take a look at one move, and that's going to be one move object. And now I can actually go and play the system. And this is kind of an interesting thing, right? So this one, the small cap A moved here, the large capital A moved there, tried to move here, then actually got here, and then D moved here. So this is a little more complicated kind of move that I can now see. I don't have to imagine. And so these kinds of views actually also become domain-specific debuggers, because they also but they also become domain-specific documentation. So what do I mean by that? Well, so if I now go back to my documentation, to my page, I can see, for example, like what's the first thing to do when you open, you take a board game, and the first thing you see is like, what are the possible moves, the legal moves in this game, right? And that's exactly what I see here. I see the initial move is this one, a regular move would be this, a move to the end would be that, an impossible move is like this, and so on, including this. So where does this documentation come from? Those are just some objects that are presenting themselves, and now we are ready to generate the documentation that we can give to the end user. It's not just technical documentation at this point. It becomes domain, end user specific, or end user centered documentation. And that's kind of very interesting as a property to have for your development effort. So if we shift away from, oh, what kind of features exist in the system, or whether or not these features exist in other systems, the question to ask is, do you get to see these kinds of, are you able to create explanations to various audiences at very, very low cost? That's the question to ask. How this is achieved is secondary. Most important thing is it possible? Can you achieve this? And so the reason we are making Glamorous Toolkit available for everyone, because we could use it just to explore it for ourselves, but the reason we make it available for everyone is actually to show that this is possible. Therefore, if it is possible, well, other people maybe can go and either use it or build something else. But people can no longer pretend that this is not possible. So so this is a thing, right? This is, if you look into a typical, Pharo environment, would not have these kinds of properties. They might be extensible because Smalltalk has been extensible for a long time, but nevertheless, the act of programming hasn't necessarily changed. And so here we're actually showing and doing it for every single development problem we find. But then there's another thing here that is, we here talk about examples, and we talk about views and how, if I can combine them into a living knowledge management system with different kinds of snippets, I can, for example, create documentation as I have here. But there are other kinds of things that I can, other things that I can combine to create new kinds of experiences. So one of the situations that we have here is rewriting code. So of course, refactoring, the automatic refactoring has been invented and implemented the first time in Smalltalk. But there's most refactorings are kept at these generic things like rename a method, rename a class, move method. Well, move method maybe less so. But here we have a situation where, underneath in the Smalltalk environment, typically you have a refactoring engine, and the refactoring engine allows you to create all sorts of interesting transformations because it has a kind of an interesting language there to specify these kinds of transformations. Some of the transformation might not be exactly necessarily refactoring, defined as refactorings, but they are very interesting for manipulating larger systems or larger code bases in a uniform fashion. So, for example, here I have a situation. I have here a method called children do, and I can see here children is nil if true, return self. Now, I want to transform all of these children is nil if true. I created here as a rewrite snippet, and I pasted this code. I just took the code from here and moved it here. And then I said, well, I want, instead of this, I want to see children if nil return self. So now if I have this, I can actually execute this, the first one. So that's the search. Then of course, I only find one in this case because only one of them is called children. But then I can say, well, maybe I can match here anything. Well, not just something called children, but any variable. Of course, here I need to do a little bit of meta programming, but this is a little bit sometimes complicated. So instead of this, we have a refactor or a transformation. We're using the transformation engine to, to create a transformation with a specification for a transformation. So notice here, if I now said I want that children to be changed, also in the replace code, it has changed. So now if I execute this, I can see that there are many more of these situations. Something is nil if true return self. And so now I can do the same here. So for example, here I can say maybe instead of this, I can say match anything, or I can tell it to the block to match anything, right? So depending on the situation. So you can see here that's in this this is documented here. So for example, I can do here match anything, and so now if I execute this, I'm going to find even more of these kinds of methods in the system. And now, if I'm now saying to replace, what do I get? Well, I get another pane with the every namespace, and in this case, I will see a view showing me the diffs of the changes that will be applied. And then if I really want to, I can go and apply all of these changes right here. Now, this is already kind of interesting, right? Because we're doing a little bit of combinations, but the one thing that I want to get your attention to is, how did we achieve this? What is, typically when we want to create or do something in a system, we often associate that action with some sort of a tool. So what kind of tool did we use here? Well, we had a page here, and in the page we had a snippet. And this snippet allowed us to specify the search, the replace. And when I clicked on the search, what did I get? Well, I get the same kind of filter object that I got when I did my query over the views. So the pragmas and the methods annotated with GTView. But now I get something else. I get a different kind of thing. So this thing already existed. And the only thing I've done was to add something in the middle of a page. It's a snippet. But the actual tool, the thing that allows me to achieve my goal, is a concatenation of these two things, the snippet and this other thing, the inspector giving me views. And so when I put them together, I get my tool. But this tool doesn't exist, in fact. It just so happens that it's interesting enough that when you put those two things together, two actions together, and you spawn the interesting object, and because the object gives me an interesting way to interact with it, I actually can create a new kind of action. So the view is like, you can think of the view as an operator, but the snippet is also an operator. So this snippet in this case, right? So here I have a case where I have Smalltalk code. Here, this is the transformation language, so a different language. So the snippet can define its own language. And so snippet plus the object plus inspectors just got me basically a new kind of an experience, right? And so without tying everything up in a tool that has very clear boundaries. And that's the shift that we think is mandatory in order to achieve that goal of controlling and molding the experience to whatever context you're in. we think the environment has to be made not out of features, but out of operators. Operators that you can extend and combine in many, many, many ways. And so that's where it becomes even more interesting. Now, at first you saw a few thousand views, but the even more exciting things happen when you start to be able to combine those dynamically. So here on the left-hand side, right, we have a notebook, a typical notebook, something that you read top to bottom. But this thing that happens on the second dimension is that this is more of a static kind of narrative. But the narrative that I spawn to the right is dynamic. It's something that I create while I work. And that becomes interesting because I can literally change the shape of my tool while I work. And that's where the magic happens. Okay, so this was one of these kind of interesting. It was an interesting problem to have. We used to have this refactoring engine was there for a very long time, but very few people know how to manipulate it. But just by creating a little interface like this, we made advanced kind of refactorings much, much more attainable, much more available for people. Now, another thing that where we spend some time on is, for example, profiling. So here I have case, I have a snippet. Here in this case, it goes to the default registry of databases. It takes the default database of the knowledge management database, and from there it takes all the snippets that are text. In this case, we have 9,700 such snippets. And then to these ones, we're going to try to parse these ones and find out what kind of links, so traverse them and find out what kind of links it has. I'm not going to go into the details of that. We can execute this and see the result. But the result at the moment is not the interesting thing. The interesting thing is to look at profiling. So what did we have here? We just have one button now into the snippet. And this button gives me now a new an object, a message tally, which also exists in Pharo. But in this case, message tally knows how to present itself. So how does it present itself? Well, it shows me the tree. But first, when you look at it in the default one, right, you see something like this. So that's the typical, thing, the representation of a message tally when you look at the implementation, at its original implementation. And the cool thing, the interesting thing about that is that it's like a printing. It's just using printing, and often sometimes on a transcript or so. And this is what typically people use very often, both for debugging and for other types of investigation into the system, which is interesting and quaint, but we can do more, right? So here we can take the same information and we display it as a tree, and not only the tree, but it's like highlighted to see how much percentage it is. So basically I'm gonna look at the places that are where red turns into gray faster, right? Sometimes you wanna look at where the time is being spent on the leaves. So these are the things there where it's not delegated anywhere. It's like it stops in the image. So it goes all the way to from here, it goes to the virtual machine. So you can see where things are being spent. Sometimes you want to say, well, what if we summarize? So we compact that thing to just basically have some grouping. We're trying to still keep the same kind of ordering in the tree, but if multiple things happen at the same time, we're going to try to compact it. So different perspective. This is much more of an elaborate type of computation, but from the point of view of message tally, it just becomes an interesting view, and it kind of works. Now, a different way, another thing here is that when I look at each of these, it will give me another message tally. Now, yeah, so this is already interesting. So if for example, if I just want to say, I'm not interested in the cost that I pay here above, I'm just interested in the cost that starts from accept visitor, which is just 35% of my overall scenario here. But this is the one that I want to focus on if I now selected it, and because here this view has the logic of saying the 100% within the scope of this object is red, and that's what it means. Now, basically, I have the scaling of the coloring again, starting from 100%. So a little thing is like this is when I take one operator and I reapply it within it. I just chose a different scope, and poof, I have a new way of just simply selecting a scope on context onto which I want to apply my tool and just focus on. But there is another thing, right? So there's one, for example, one other view here is, so the same happens here with the summarizing or the, which of the leaves are being executed just from here, right? So I can get this answer. But the same thing I do here when I have the source code for a message tally. So now essentially just by concatenating these two views, I basically get a browser of the code. So I can see, oh, this amount of time is being spent in this particular method. There is no tool. There's just a concatenation of some objects that are showing themselves. That's it. And there's lots and lots of magic that we can just create just with this. So one thing that we sometimes this kind of profiling is interesting, but often it's not, let's say, it's not enough. So for example, here we created, we have this whole Glamorous Toolkit runs on its own graphical stack that we've developed over the last 7 years. And that's already in production since at least 3. And here we have, when you're building this graphical stack, it's really interesting as an engineering problem. And so one of the things we have here is we have all sorts of tools that are specific for just the graphical stack. Okay, so here I have, for example, here I have a profiler. And this profiler is opening a different window that you're seeing here. And let's say that we want to, I'm going to inspect this again. And I just want to see what happens. There's lots of laziness in this, in the user interface. So in this case, for example, there's a stream, but also the rendering is lazy happening. So there's lots of laziness, and sometimes laziness is actually nested. So it's difficult. It can be difficult to to profile normally. You want to really go into the details of or want to have the profile. You want the profiler to take the details of the underlying framework into account. So let's do that. So I have here the profiler, and what I would do is I'll say I want to start, and I'm going to go here, and I'm just going to scroll through it. And I'm going to stop. So I did a few of those. It's not so well, it doesn't work exactly nicely when there is a zoom in there, but it's good enough. So
we cannot see any additional window.
Oh, there's no additional window. Let's share the whole screen then. So I was here. I was scrolling through this. Let's reset this and start it again. I'm here. I'm scrolling through this window. And these kinds of the layers are coming back here. So what you're seeing here, these are the frames that I have instrumented. And so we took the whole execution and we now split it by frame. This is kind of important because when the frames drop, for example, in this case, everything is under 16 milliseconds. is they're going to become red. And then the reason this is so slow is because they are here. Let's do it again. So I'm going to have do it this case again. I'm going to start now. I'm going to go here, scroll. This is very slow when it's being shown over Zoom, but it's good enough. We get these, we get some frames that are slow. So these ones are fast frames, and the red ones are slow frames. So the interesting thing about the frame here is that if I click on one of these, I get to see where the time is being spent. So I can see this kind of heat map if I want to. Of course, I can also see the tree. I can see the source code of where the signal came from, just like I was seeing in the message tally. But interesting enough, I can also connect. So this one is a custom kind of signal that comes from the code, but I can actually also connect it with the tally. So this is the actual execution of the code, sequential, exactly like I saw before. So this is one way of splitting the execution by frame. So this has meaningful. It's meaningful from the point of view of the graphical frame, but I also get access to the actual, all of the execution, the raw execution, the raw tree for every one of those steps, which is kind of interesting because now I can have, on top of the basic profiling, I have my custom profiling, right? So here, even here, I can have these kinds of steps, which are, for example, event processing. So if I look at the event processing, I'm going to look only at the tally that appears there. But one of the things that we saw recently was we saw that sometimes, you take a look at the execution. So the trace gives you information, but sometimes other kinds of things are giving you information. For example, unneedy types of executions. Or something that you can't necessarily see. You can see the execution that happened, but you don't know whether it was needed or not. So, for example, one of the things that we've done here, this is recently, and we use this one to optimize the debugger more than an order of magnitude, the speed of the debugger. What you're seeing here is a preview of the screen that we were profiling. And here we are highlighting the places that require layout and a reprint. So what we are seeing here, all of these expensive things that happened required, we can take a look at each of them and see how much it costs. So this is kind of an information which will be, this is not taken into account for here, or like it's the reason why something took long. This reason is custom for the framework. So we made the profiler know about the framework, and therefore the views now give us information about the reason. And that's really interesting. And it's harder to describe, because here again we don't have, it's just some concatenation of views and objects on the screen. But the magic of putting those together and imagining what kind of views would be interesting, and often because you want to have the view, like in the case of the move in the Ludo game, we wanted to have a view, but we didn't have an entity.
Hurry!
You didn't have them last night?
I had a tiny bit. You saw it.
So we didn't have an entity, so we created a view for that entity, right? So we created an entity for the view just to have the place to host the view. And this actually helps you find models that are otherwise hidden. So it's a really, really interesting feedback loop. And then the other interesting thing here is that
it's probably more than I can eat here. Have someone.
Jan, I think you're unmuted by mistake. Thank you. So when you have when you're able to describe problems, like these are really, really detailed, like we're talking about some details about how something is being drawn on the screen. It's far away from typical end user interests. But when you're able to describe such details in so satisfactorily, right? It's just a source of joy. And it's really hard to explain unless you actually get to see it or to live it.
No, that was amazing. That was pretty awesome. Very awesome, in fact.
Very awesome. Yes. So thank you. Now, interesting enough, right? We can do the extent to which we can go and create customizations is bounded to a good extent by our imagination. So for a long time, we had the possibility to extend the inspector, but we also had the possibility to inspect the debugger. But it was only recently, but still was not. So in the inspector, we had like thousands of views. It was easy to create them because we found an interesting way or a good enough way to express those extensions. The debugger was interesting, but not so it was not so prolific. So the extensions. And so more recently, we worked on this idea of moldable exceptions. So where we can define custom-made debuggers by just extending the inspector, the exceptions. And so, for example, here I have something like this. I get two pieces of text. I can go and inspect those. This is one string. This is another string. And if I execute them, right, I get a debugger. Now, a default debugger shows me things like this. So I can see here actual and expected, but I get a new debugger that in this case is just specific for the exception, and it gives me a diff because that's what I'm interested in seeing right now. So these are the kinds of things that we can now start putting together. Again, the interesting thing about this debugger here, this part, is where does it come from? Well, if I inspect the exception itself, I get an inspector over the exception, and I can see that there's a textual diff view. So a view over the exception becomes a debugger, or it can act like a debugger when I'm actually looking at the exception live. It's kind of interesting because that's exactly what a debugger is. It's just an inspector over the execution stack. And this is where you see that this idea of just focusing on the object is kind of important and very, very powerful, because in everything is an object. It means everything is visualizable, everything is explainable. And then the same we can go for here, for example, when I do, for example, just an assert 1 equals 2, there is no exception because I'm not using assert colon equals colon. Right? This is a different way to write the assert. So, and the debugger, the exception would be a different one, and so. Yes, so a similar one, another kind of thing is here. So here, for example, we see that we're validating the views in a certain object that we have here. And here it tells us which of the views actually have problems. So I can take a look at them, and it will tell me, what the exception is and whether or not it worked. And of course, I will only get these extra things, the exceptions and where the exception happen for the views that actually have such a problem. So this is a little tool, a little kind of helper exception that we use when we are actually testing the views. So again, just playing with objects, meta levels, and then you basically can create new kind of experiences just by concatenating operators and combining them. And I'm not going to go into all of these, but maybe this one is interesting. So here, for example, we have a situation where I have a view, and a view should always return something, but it should never return itself. So it's wrong here. And so this exception tells me that this is wrong. And I can say here, well, actually fix and retry. Now notice, what is fix and retry? Well, it's a refactoring change. And it basically it has to add empty in all of these things. Now this view, this diff view that you're seeing here is the same that I had used, or it's just another view over the refactoring namespace, or the refactoring engine that I used in the rewrite. It's the same thing, it's just concatenating in a different place. And so now if I execute this, it will actually produce, it fixed it and continued, basically. And the same thing happens here. So in this case, we don't have a full, another exception, but we have a situation, just a second. We have a situation where the matrix is, we're executing some code, and there it's using somewhere internally, it's using a matrix and tries to invert it, but it has a scale 0. Because of this, it cannot be inverted, and it raises this error. There is no exception, there's no custom-made debugger here, but there is a different, there's a view directly in the default debugger. So then in this case, we get to see how, this is the decomposition at the level of the matrix, right? And then the preview of the matrix itself. So these are the kinds of things that now we can do to extend the debugger as well, not only the inspectors. Was there a question? No. Okay.
I did want to ask, so when you click on something on the left, you get something on the right, sort of like a 2-pane sort of scenario.
Yes.
If you want like 3 panes, like clicking something and then you see 2 visualizations of the same thing, I'm wondering, I noticed you had a popover on one of them. You kind of got around it by sort of on the pane, you could pop over to see something. But I'm just wondering, is it just a bad idea to have the 3-pane view in your experience, or?
So no, it's not a bad idea at all. So let's say, for example, I'm going to spawn another one over here. And now if I do this, then basically can see 3. Of course, ideally, we want to do this one more automatically, right? So I can do it like this. But this is possible to do, and we sometimes do that. So you can customize how many of these columns you want to see. But sometimes you want to see 2 columns, for example, right? So here we just see 1 column following by another one. So if I want to see an alternative column at the same level, I cannot necessarily in this interface. Now, so that's not that it's a bad idea. We were just looking for what's the simplest idea. There are all sorts of possible interfaces. And what I believe is that in the future, just like we have now lots of languages, there will be lots of environment languages. Because it's inevitable. This is so powerful to create experiences that when people will come up with other kinds of interaction, languages similar to this, or this same idea. So for example, an infinite canvas, of course, is an interesting thing where you can just spawn various things. But we were looking at what's the simplest thing, something that is.
I suppose you could get a composite. Is it a browser on the right hand side?
Yes, you can.
A composite could have two of them inside it, couldn't it? So here,
for example, this is a composite that is there hidden on a tab and so on. So lots of things are possible. The question is, like, we want the people's imaginations to start going in this direction a lot. So there is the infrastructure is here for people to actually play with this directly here in this environment. But also other environments could also be hostable could host such
I suppose it's exploring the design language of the moldable environment, isn't it? Trying to come up with the concepts that play well with each other.
But first we wanted to ensure that that moldable development is a space. And now we know it is a space. We know it's a whole new way of programming. Well, it's not like it replaces other things like testing or continuous delivery. it complements them. It's a new feedback loop. And yeah, whenever one of those happen, which is not so often, but whenever one of those happen, then once people start realizing, lots of things change in a reasonably short amount of time. So the way we look
in
at
a way
Glamorous Toolkit is that it's the beginning of that conversation. Sorry.
In a way, it's like without having to feel guilty about it. You know, like in the normal flow. Well, not in Smalltalk, but in other language, TDD is quite regimented in a way. And in Smalltalk, we always had the ability to kind of swipe something and inspect it and debug it and play with it a little bit while writing the kind of standard tests. And in some ways, you kind of almost felt a bit guilty doing that extra playing around a little bit. And I think you've almost taken it and embraced it and sort of said, well, actually, it is another form of debugging and testing. And if you've got the tools to let you do that more easily, you don't have to feel guilty in a way, do you? You can embrace it and do all of it at the same time.
So it's not only that. So it's true. Like the amount of joy that you can get out of just this, making the system show you the problem in exactly the way you imagine it. It's just, yeah, you have to get. One has to be there to feel it. But the most interesting thing is so that the joy actually correlates with productivity. So you don't have to. It's not like you don't have to apologize. People will want you to do it because it's just way faster. Because the bottleneck in software engineering is how you reason about systems. And the reasoning is actually not the actual execution in the head, but getting the information into the head. That's the problem. And this is what this one solves. And so, there's a lot of conversations today about how we would get machines to write summaries for us, but we don't know how far our mind goes if the information actually gets to our brain. So, shall we continue?
Yes,
we shall.
please.
Okay, so we just played with Pharo. Glamorous Toolkit is implementing Pharo, and we played with Pharo. Here we looked at different kinds of tools, which are probably quite different from the default Smalltalk experience or even the Pharo one. So that's one way to look at those differences. But let's see other things. For example, Gemstone is another way to another thing that we can work with. So here I have already a connection to Gemstone. It's live, and I have here the concatenation of two strings, and I can get hello world. But in this case, this is not a local Pharo object. This is a remote gemstone object. I have a remote gemstone working at the moment on my machine, and I just connected to it. And so this is a specialized snippet, a gemstone snippet, and I just executed the code into that. So for example, I can go and inspect object here. Notice here how we have the syntax of gemstone. And then even more interesting is that this the snippets that I have here at the bottom are also knowing that this is a gemstone. I'm looking at a remote object, and so it will propose me gemstone snippets by default. So here I already have written a few. So for example, here I get if I take a look at how many classes, subclasses exist, and this is one of our extension, we have 236. And then I can actually get all the classes that have more than 100 methods. So I can look at one of these. And so now I can look at the definition. I can also take a look at the methods list. And then this one will give me a view of the source. Now, all of these views, they actually come from Gemstone. They are not defined locally. They are defined in Gemstone. Well, except for the last one, I think. No, even the last one. So, this one is local. So it's possible to extend. So here, what happens here is the following. We have an object, which is a proxy object to something that is remote. And the remote object, so it's implemented in whatever the target environment is, the remote object knows how to serialize itself. And so based on that, we can basically show it locally. Christian, you have a question.
So yeah, so obviously, if you go back to the code thing, you have a different visualization for the code. So here you cannot go into the sub-methods to open them up. Why is that?
Oh, because we didn't implement it.
Sure.
Sure. We
You
just
implement
didn't
all the
implement.
code views yourself on the fly all the time. So you don't have to like standard. This is my standard code thing or so with all the features.
This is a code editor for Gemstone,
Okay,
which is
so
not
text.
might or might not be the same as the one from Pharo. So
Okay.
in this case, the styler is not the same. So it only has the colors. So this to expand the triangle is actually just another styler.
So is it
So-
not interesting on Gemstone to navigate through the
For sure it
methods?
is. Yes, but we didn't implement it.
Okay, thanks.
There was no, yeah. So of course it's absolutely possible. So even more interesting is this one here. So up to now I just inspected, but then I can also spawn a debugger. So this debugger, you see on the GT side, the local one, it says, well, I'm waiting for something that happens remotely because I just executed something, and then two more debuggers appeared here. Well, this is the standard one, which is a bit faster, but this is the one that is going to be the default. So this is now a Gemstone debugger that actually acts exactly like the local Pharo, the local GT debugger. This is a local GT debugger. This is a remote Gemstone debugger. And they basically look the same. And they act the same. So with all the possibilities that spawn from it. So here I can inspect and then I get the remote, a remote object. So what this means is that Glamorous Toolkit is also by default also an environment for working with Gemstone, which is kind of interesting. Gemstone, for those that maybe don't know, is a highly exciting object-oriented database that is Smalltalk based. Now, if I take a look at other things, for example, here's an example of GraphQL. Now, different people will have different opinions about whether or not the GraphQL is an interesting thing. I want to debate that, but let's imagine that we actually care about it. And so GraphQL is basically a way to, it's like an alternative to REST calls, and you can go and query your server based on this. So what I've done here is I took a specification of GraphQL from GitHub, and I can go here and browse it like you do with other like, so if you go on GitHub, there will be a help where you can go and do the same things. But here is just basically this is just a view in the context object. So that's how we browse it. Then of course you get to see this. So you have this is now a snippet inside. It's a snippet inside our knowledge base. So, and this snippet is now GraphQL aware, so it knows about the GraphQL programming language. And then here we can get completion. So this is something that you get out of the box pretty much in any GraphQL editors, right? So that's kind of interesting. And then I can, of course, I can go and execute this. I can provide here variables and queries, and I can execute this. Now, of course, we can do a little bit more than what is typically available because we can. So, for example, one thing we can do is rename. And so here I renamed a variable, and it renamed it here, but it also renamed it in the other language, which is JSON in this case. So I can accept this one, rerun the query, and I get the result. So it's kind of neat from this. Now, one thing that I just want to spend a little bit of time on is paginating through a query. So sometimes you have a query that is longer, right? That's typically what you want to do. The thing is that, so this one here is a query like this. It basically says, I want to find out all the repositories, and I'm going to give you the amount, the login, and so on. And in order to find out, like this organization here, I want the name and the URL and the repositories. And in the repositories, I want pages. So I want to paginate this. And the way you deal with pagination is you have to add this little extra snippet. The pagination information has to be part of the query that you send to the server so that the server can populate it and give you back. Because basically here you're going to tell it, it will tell you what's the current cursor, what's the end cursor. Right, so if I now execute this, I'm going to get this. So I have, in this case, I just said, I want 5 of them, and I'm just going to look for all the repositories in FinCom. And then I'm just going to go this, I'm just going to get this 5, which is nice. Now, what do you do with the pagination? And this is where GraphQL literally stops. Like, in order to do anything meaningful, which is, like if you want to browse anything that is more than 100 items, you will have to take GraphQL and combine it with another language. Now, the way typically this happens, you're going to take this string, put it into some code, Python or whatever scripting language you might have, and then you continue writing in that language. And we're thinking, well, that's kind of quaint, but we can do better. So here, for example, we took this, we take the query and we put it in a variable over here. And then this variable, so if I inspect this, it's one of the GQL success result, but it also has a paginator that can be attached to it. But now I'm in an imperative language. So in this case, I'm actually using a Pharo code. So I took the thing that was resulted from GraphQL, and now I'm continuing writing code in Pharo. So now if I execute this, I get a paginator stream. I see the original JSON, but then I have the items view. And this one now lazily just wants more and more and more because it just is what I'm looking at here. And so now we get that, right? So now interesting, right? Is again, not only can we get the thing and the chance to see systems differently, we also have the ability to combine things because in the snippets can also be combined with themselves. So there's every snippet has a language, but then it's not just that they handle it, but they share a space. So I can actually take a reference from one language and pass it to another language, which starts becomes kind of interesting. We can do. By the way, this is the amount of repositories that our little organization is putting or is creating. So
the paginator that you typed in there, is that like a variable in that browser, and then that's the link is like because there's the variable and you use the variable.
So this one, I put the name here, and then I populate it with the result. Then this one is a Smalltalk object, so it's a Pharo object, and it has some extra. We can just take a look at the code here. Basically creating a paginator stream on this result, and then there's a paginator. I get a paginator stream object that knows how to do pagination. There's nothing fancy there. That's exactly what you do. You're going to have an object that keeps track of the cursor and just page through it. Just whenever you do next, it's just going to take the next page and that's it. So, but just because I can take this result, put it here, there's no string, there's no copy pasting. I can just go and prototype, actually do actual work right here. But then we can take it a step further. This becomes really, really interesting. So what if I still hate writing this? This is just like, what? Do I really need to do this? Can't tool do this for me? And so that's exactly what we have here. It's the same query, but without that extra boilerplate code. So we have exactly the same thing. Let's see what it does. It gives me the last, the 5. And then I'm going to do this. I'm going to look at this. And it works. But the question is, why does it work? Because GraphQL says it will only work if you're going to put me this boilerplate. And so that's one of these kind of interesting questions. And how do you document this? Because obviously somebody injected this, but how, who, when, how? And so here, this view, for example, the paginator stream has a view saying, well, this is the query that you gave me, and this is the query that I passed to the server. And it just knew how to, it also documents which part of it it wrote for me. So for example, if we want to go and get a little cheeky here, let's say we just don't want these ones. If I execute this and then this, then I have this one. So it knows how to inject only the ones that are actually needed. And so again, this view here, we needed it to debug, to ensure that the algorithm works the way we think it does, right? To get the quick feedback. And so now it becomes documentation.
The question that Tim had was more,
Sure.
when you have that variable repository query, is this a variable that is, let's say, local to this play field or
Yes.
workspace that you have here? Or is it some kind of instance variable on some few extension or whatever?
No, everything is right here, just on this page, in this notebook. Okay, so what about other kinds of things? So here we just saw GraphQL, no longer anything related to Smalltalk. So if Gemstone was kind of similar to Pharo, here we're looking at GraphQL, and the integration is very similar. It's basically practically the same. So some snippet, some inspectors, that's pretty much it. So here, for example, I can take a Postgres SQL, take a look at these. I can take a look at tables, and I can execute code here, right? So, for example, here, select star from drivers, and I can execute this, and I'm gonna get tables and columns, which is kind of nice. But it requires one to go through this Smalltalk, right? Writing some Smalltalk. Maybe some people don't want to write Smalltalk. So here's a different way to do the same thing. There is a login snippet over here. I can accept this, and I can get the same things. So here, for example, I can take the database, and from the database, I can take the schemas, and from the schemas, I can, for example, go and take the ER diagrams. This one takes a bit of time, apparently. It's actually taking it remotely. It's in somewhere else, the database. So we have a little bit of an ER schema. So this is something that someone without any knowledge of Smalltalk would be able to actually go and use. And then, of course, the same thing here. Here we have a Postgres SQL snippet. So we can have this. So I can go and do the same that I did before. Select star from drivers. But even more interesting is maybe this one here, select star from races. Because here I have the default ones, the table and the columns and so on. But I also have this. And now this one actually is a custom view, written indeed in Pharo in this case. But it just gives me a summary of what happens. Right, so this is the Formula One races, and I just see some of them. So some of the columns, I don't see everything as it is here. I see it more of a human-friendly kind of information, right? And then similar things you can do if you can do it on the level of a table. So here, for example, we have the top 20 overall wins of Formula One by country. Okay, so these are people, and then they are colored by country. And then, of course, you might want to say, what is the country? Well, of course, and you can click on it, and then it tells you. In this case, it's British, and this is German, and this is Dutch. Okay, so this is how you deal with Postgres. What about Python? Well, interesting enough, we can do the same things. So here, for example, I have a file name that I take. I have an application already running. I've loaded all this code. I can define it here, load it again, and then I can go and inspect this. Now, this is a Python snippet, just like this one was a Python snippet. And when I inspect this, I get again a proxy over a Python object. So I'm actually looking at the Python object. But the most interesting thing here is that these views are actually defined in Python. They are not defined in Pharo. So you actually get to play with with the inspectors, so custom-made inspectors, but in this case, they're not even implemented in Pharo. So you're just going to use GT as if it's normal, just any other external tool that you don't necessarily want to know how it's implemented inside. There is a question from Alberto.
Yeah, I kind of missed the last part on the Postgres. Was that a custom view on a specific table?
Yes, there were a custom view on a specific table and a custom view on a specific query even.
Oh, great. Yeah, I hadn't seen that part. That's pretty good. Thanks.
Right. So here we have, as I said, snippets for we can extend the inspector, for example, for working with Python, but from just purely in Python without seeing any small talk. And then the same thing happens here. So not only can we do this, but we can also browse Python, kind of like how we do if you would do it in a typical kind of development environment. Christian, you have a question.
Yeah, so did you implement Python syntax in Smalltalk? You're still in Pharo,
Sure.
right?
No.
So
Yeah, this is running
remote
Python
connection to some Python
yes,
server kind of,
runtime.
and
Yes.
you just basically do strings back and forth.
There is a proxy model.
Okay. Okay, thank you.
But
So you don't need
there's a
your
proxy
own
model.
syntax. You take over the formatting and the coloring from this Python server.
So here, the syntax is actually, there are two things that are at play here. Let's see if we can get this one. So you can see completion comes from a language server through the language server protocol. So similar to basically what VS Code is using. But the syntax is actually coming from a parser, Python parser that is defined locally.
Yeah,
so
yeah.
In this case.
Yeah, I was thinking.
Right, so we can have this, but the interesting thing is that you can do, you can browse things like you would in a typical, development environment. Now here I have an actual very simple sorting algorithm, and here we wanted to take it a step further and help people improve the performance of their algorithms. And we don't want to. We looked at the state of tools in the Python world, and it's not particularly exciting. We thought we can do a little better. So here we have a situation where we can add annotations around methods. For example, if you want this one to be traced, but we can also send or emit signals from inside the runtime. It's kind of interesting because you can do performance, and then afterwards you can take some objects. So here we have a generic one, telemetry signal. So basically a lamp sort is just a sorting algorithm. And the most interesting bit here is how do you do the partitioning, right? So there are two situations when you are, when the pivot, when you're less than the pivot, then we are in this one, smaller than pivot or larger than pivot. So, and then here we created a custom-made, we created a custom-made signal. And so what happens when we run this? When we execute this, we get a remote telemetry signal group. This is one coming from Python. And here we can, again, take a look at things like this. So similar to what we had for message tele locally in Smalltalk. So of course we have the same principle here. This one knows how to present itself, where it is. It knows where it comes from. right? So it's the same idea as we had for message tally, but now applied to Python. And then, of course, you can also have the things like this. So interesting enough, this map. So if I now look at this tree, where is the tree implemented? So if I alt-click on this one, it actually comes from, I now do, there's a little bit of meta programming here. So we get to see where it comes from. And it actually, this view comes from Python. Now this view over here, the one that shows me the flame graph, comes from, this one actually comes from Pharo. So if I want to implement it here, I implement it here. If I want to take it from the remote, I take it from the remote. There's no particular limitation into what I could do here. This is kind of nice because we can then play. So interesting enough here, as I said, is that we can get all the way to not only do we get the tree of execution, but we can also take objects. And for example, we worked on optimizing a reasonably important algorithm that they had a problem with. It took about 3 minutes, and then they wanted to bring it to a couple of seconds. And the way we did it was basically using this kind of infrastructure, and then from the different places in the trace, we could serialize objects that we could then visualize in a domain-specific fashion. And this is what people used in order to come up with a new algorithm. So we only facilitated it by just creating the environment in which people can come up with their with the algorithm. And yeah, at the end it worked. So, but the cool thing here again is that here we have a complete environment, which is not aware that it's inside Smalltalk. You can if you want to, but you don't have to. It's there.
That is too quick. So just you have to write code which is aware of GT Toolkit, right? Glamorous Toolkit, because otherwise you wouldn't be able to define these views. So
This
code is defined in this environment, sent over to the language server, is interpreted there? No.
No. This one is not related to the language server. The language server is only for completion and references, for example, things like that. Here we are actually, the information that we have here, we got it from the runtime.
Yeah, okay.
The runtime accumulated something, the signals, like message tally accumulates it, for example, in the Pharo image, and then we're just showing it here. Same idea.
Okay, but we're still talking about somebody who has to execute this Python script, right? So you have to, like the Python server, right? You send code from this environment to the Python server, which knows about this environment, right? So the GT stuff. So that's why you can define it remote, which is executed actually remote from that image in your image. So
there's no image on the Pharo, on the Python side.
Python is not useful at all. It's just a proxy or an execution outlet for your local environment. This is cool. So that's
no. The Python code is executed by a Python machine.
Yeah, exactly. But
GT is only a client
from this environment.
Yes, it is remote. It's here. It says it's connected to localhost 7022.
Whatever, right?
Yeah,
but it's not in this process. That's the point.
It is not in this process. No. It's somewhere else.
It could be executing code, which is only meaningful in your process, which is kind of interesting.
No, it can be. We can connect to an existing application, so we can run Python and then connect to it. This also works.
But I mean, the Python doesn't know your GT toolkit, right? I mean, it doesn't know how to show the view.
Oh, yeah, well, this thing happens.
GT in Python fully implemented.
So, Tudor, this is the point I'd like to clarify as well. So when you say the Python is creating the view, right? There's a Python engine, you have a remote proxy to it, that's all fine. It computes things, it sends you serialized results back. But when it's computing a view that you're going to render, what is it actually computing there? Since it doesn't have your complete graphics API and so forth.
No. Indeed, it's serializing. It's the signals here. It's basically this is what it computes.
Okay, so it's just those signals that you planted them in the code, and it's building that representation, and that's the view that you can use.
This is this is the structure of what is being passed over the wire from Python to Glamorous Toolkit to render the views, right? So we don't have it. They basically, on the Python side, we only produce the serialized version of the view enough,
but the code
so that we can work again with the objects.
Is coming from this environment, right? So you send over
the code that has produced this JSON was executed in Python. There is Python code.
So what Python does know is this how to create these structures, right? It basically has a description of your AST, your views.
Yes.
Okay.
Yes, but this is really small.
Okay.
Right? So once you basically, if you want to make it aware, just a second, Christine, if you want to make a Python system code aware or usable in Glamorous Toolkit in this way, then you have to import. This in Python, in the Python code. That's it. You have to import
yes.
And this one is published is publicly available in Python.
Yeah, this is not the point. So I'm talking about the more abstract general structure of this code. So your process we're looking at right now is producing source code for another language in another process, which you send over remote, wait for the execution in that remote process to get results which are only possible to interpret in your own environment. So the results
not possible.
Come on, details. Get the picture, the big picture. So you have two processes. This is one, A. B, you're sending over some code which is executed. You get back something which is useful here, and you can do something about it. So this is all automatic. This is all cool, but it's it's an interesting structure, but it has nothing to do with Python or anything else. The interesting thing is, what do you need on this side, and what is needed on the other side to support this? So
on the other side, this is needed.
Yeah, right. So you need some native code in the target process, right? Which can execute these things and is able to signal back results. Yeah. So
this is already part, but we can also.
But that can be also like COBOL, right? Or Fortran or whatever. So what kind of parsers or things you need in your environment here to make this possible? So you need some kind of language understanding of this other system. I mean, you cannot just say it's a black hole and I said something in there.
No.
Hopefully something back, right? So how is that other system represented here in your environment? I mean, it's not just an endpoint and you say, ooh, let's see what's happening. That it's right?
It's
Postgres, it's GraphQL, it's whatever other remote system there.
Exactly. Yes. So in the case of Gemstone and Python, GraphQL and Postgres are simpler because you ask things and it gets you back JSON. You don't have to do anything. You're just going to interpret this. In case of Gemstone and Python, we need to have a proxy model and a way to link the environment. So communicate, sending instructions over. So in this case, both of them support eval loops. So you need to hook to that eval loop, send over instructions, and then get basically back some references and be able to keep track of those references, have a proxy model on your end, also some sort of management of those objects on the remote so that they don't get garbage collected willy-nilly.
It's a low level of communication. Fine.
Well, this is what you asked for.
But what do you know about the syntax, about the semantics of this other target system?
So the syntax is not needed unless you really want to, to have highlighting, for example. Then you need to know syntax. If you don't, you don't.
No, you don't get the point. Sorry. Okay, we can take that off.
Never mind. Okay.
Sorry for that.
So, but basically here there is an editing part. There is there's a link to the runtime. There is a proxy model on top so that we can actually get things. And there is a little bit more implementation on the target to give us, for example, in this case, give us back views and the signals. So this is what we have, and those are implemented in Python. And so together, put this thing together, and you have this kind of an experience that you kind of could get in any other development environment to some extent. So sometimes you can, sometimes most can't. Okay. Should we continue? Let's see. Up to now, we played with programming, but is this all of it? Is this everything we can do? And the answer is no, because otherwise I wouldn't ask the question. So here's an example of actually connecting to social media. So I have here a snippet that is connected. In this case, I'm logged into Blue Sky, which is a social media that actually allows you to connect to it. And I have here one message already written, Glamorous Toolkit, blah, blah, something with a link and a preview. And if I now press this, it actually gets published. So now it got published, and now I have the second message here. And because this second message already, it knew that this one was published, so the second message will be published as a reply to the first one. And now, of course, you should not trust me, should you? So let me, okay, just a second. Okay, so what I'm going to do now here, I'm going to go to another knowledge database, and I'm going to, I am going to connect. And if I now connect, this is another snippet. I'm now connecting to the Blue Sky remote, my account. And in this one, I can see that I just posted this, right? I posted this one and then this one. So this is just the messages that I just had right now. And again, they are just over here like this. Now, of course, we can take a look, for example, at followers or at following. And then when I navigate there, I'm gonna see their postcards if they have any. It doesn't seem to have any. Something happens here. So this is that. And now there are all sorts of things we can do here. We can, for example, of course, go and do the same thing from the command line. But interesting enough, Blue Sky has a way to describe the protocol, which is called the AT protocol. It has a way to describe the protocol in a way that is self-describable. So it's all JSON, but it's kind of interesting, but it's also a little bit convoluted. So we have the infrastructure to take all of that, generate, in this case, Smalltalk code. This was a project that we did just to see how far we can get with something like this. But even the one that I want to show you here is what happens when you when you look at this code. So this one here actually is, this is how the JSON description looks like. These are describing the different parts that are that the server will show back. So it's kind of, in a way, not somewhat similar to GraphQL, except that it's actually everything goes through REST. So all the REST endpoints are described in this language. And then, of course, because we needed a way to go and reason about this, see what happens there, actually, how are those things linked, we weren't satisfied with just going and reading JSON. So instead, we built this. So we have a way to now browse. And this browsing is actually happening in the same way as we were doing before. So it is like I was doing in the case of for example, here, in the case of Python, for example. All right, so we have similar structure, but in this case, it's showing me this JavaScript, this JSON, but not just showing me JSON, because on top of this, because I know what the structure of the JSON is, I can make the environment aware of this. And so, for example, the syntax highlighting highlights me inside JSON that this string here has a different meaning than this string over here. And so this is why, because this one is an identifier. Not only this, but it actually is also able to, if I now remove this, and I actually get completion inside the string in the JSON, right? So if I do this, and then there's a little circle that appears over here, and if I click on this, it actually gets me to the definition of that entity, because that's what you do when you want to program something, right? So why would I want to go and use now? Because this is where the, people say, well, why do this? Because you have all these tools that already exist. And the thing is, you don't. Software is so contextual that you almost always will need to create something that is really, really specific to you. So in this case, right, you have an actual infrastructure significantly developed, and people, you will find themselves editing them in plain text. It's why would you do that, right? And the thing is, you don't have to, right? And so the interesting thing here is we took a problem that didn't look like a development problem. First of all, you could just have conversation like threads, for example, which is just a little tiny thing. But normally when you go to a social media environment, what do you see? Well, first thing you see is the thing that you need to read. Why can I not start with the thing that I want to write? Right? And so little changes like this, if I choose that, I can, because this is my space, it's not their space. And on the other hand, right, similar things happen when if I go again to if I'm gonna log in again here, right, and I take this this thread, for example, I might want to do queries that are just me, they're highly specific for me. So here, for example, I have a query which gives me, I want to know not just all my messages, I want to know all the root messages of all my threads. So what happens here, and if I execute this, it's a stream, of course, and it will give me all those things. Notice how they are /1/1/1, oh, 1/1/. So because this is the root of the threads, right? And this is a query that I wrote against for my own data, but without having to download the data, just using the remote interface. So it's a way for me to control how I relate to an external service. And how interesting, the interesting thing is, it's like, even if the environment has this very simple way to concatenate things, just with this simple language, I can express all sorts of patterns for which people typically think in terms of separate tools. And at the end of the day, that is what that's what Glamorous Toolkit is, right? Because it's difficult to say, to put it in a specific box that already exists, because that's the whole point. The way people reason today about computation in general is very constrained by the borders and the walls of tools. They think in terms of tools, they decompose problems in terms of tools, and we think that it's much more interesting to get the tools to come to the problem, rather than get the problem to the tools. And a whole new world is actually possible. And not only we started from the development problem, but at the end, it turns out that it has all sorts of interesting ripple effects, all sorts of interesting implications. Okay, so at the end, this is what we do. We want moldable development is about this way of thinking about systems, and particularly started to focus. Our focus is first and foremost on how we reason, how we read, how we get information about systems. It turns out that an environment made for that also has presented itself all sorts of interesting opportunities for writing as well. Just like you saw here, a few ways to compose things, for example, for GraphQL, for social media, for Python even. But the first problem that we want to solve, and we think that's the unsolved problem today, is how do we reason, how do we make decisions about systems? So what I'm showing you here is a working map, which we use to reason about this space. So if you have here, both developer business or organizations, they always have a specific problem. And in order to reach a decision, you first have to have a hypothesis for which you want to gather information. So have a way to synthesize the information, then use the information to actually make the decision. Now, today, this decision is actually fueled, many times is fueled by views over the systems that are created manually. And we think those are interesting, but they don't document the system. If you have a manually drawn diagram, for example, about your system, that diagram doesn't document the system, it documents your belief about the system, which, if you're lucky, they're the same, but this distinction is very, very important. So we think that any conversation about a system should be intermediated by the system itself, not by someone interpreting the system. So I should always be able to go to where the information is and get answers, which is the thing that we've actually gone through today. Perhaps so those that have survived so long, we've gone through like maybe a dozen domains, and we've gone through different kinds of meta levels, and we could still have the conversation. But all the conversation was not me describing things to you, but actually showing you a living system that was carrying my message. And it's a system that you can actually download or take this or get the same kind of information and maybe reach different decisions. This is perfectly valid. But we just think that the current state of the system should not be a matter of debate. There are lots of things. Building systems is hard. We shouldn't make it harder than it should be. So the reason today these views are being created manually is because actually people gather information typically through manual inspection. The reason they do this is because tools are rigid. They have these walls between them, and those walls are really nice for the problems that they are really made to address. But as soon as you're a little bit outside, or as soon as you need to combine multiple things, then you have to resort to manual work, and that's the problem. And so we think that an environment that is moldable will offer this new way of thinking, which is transforming this manual inspection energy, which involves reading, into creating tools that do the reading for us. And these ones basically then will generate the views, and that's the information that we want to use and fuel our decision. And in practice, one of the things we've learned is that it turns out that it is possible. It is possible to actually not read code for most of the time, which we don't. When we develop whenever we work on anything, could be a Glamorous Toolkit or some external systems, we end up reading much less code than is typically happening today in the industry. So that's what moldable development is, and that's what we see Glamorous Toolkit to be. Is primarily actually has these three things. So as I said before, it was a research and a research vehicle to see how far this idea can go. Then it was a way to actually do actual work, so validate it in actual concrete systems. But even more interesting is that it's a self-documenting case study. So this is a significantly large system. It has more than 1 million lines of code, which for Smalltalk is quite a bit. It actually involves other languages as well, for example, Rust. So, and the reason it's not the size that is the most important, but it's the fact that these ideas can take many different forms throughout the environment. So one can look at the environment and learn from it, basically. Question?
Tudor, thoughts on what AI is going to do to this landscape?
Ah,
Because
I knew you're going to ask that.
well, there is a real issue, right? That one of the things that the AI will facilitate is gluing different environments together,
Yeah.
essentially. And
If the,
that's in a way similar to what you're doing.
no, that yeah, no. So I'm sure that people, will patch things with enormous energy because whatever. But it's much more interesting to actually use a mold because this is a language. So once you have a language, AI generated environment, like we don't have to code this by hand. So that's what I think is going to happen next. So this can be, to a good degree, commoditized.
We should have a long conversation about this.
Yes. Now the next presentation will be about how we do this in practice.
I was thinking about this today because I use ChatGPT to explain my routing tables.
Yeah.
I said, here's my routing table. Can you explain it to me, given that this IP address is an external one? And then I thought, hang on a second, that's the sort of thing Glamorous would like to do. Explain
Yes.
stuff.
Yes.
Parse stuff and explain stuff. So I thought there was an overlap.
Yeah, and so the let's maybe call it this one green, just to represent it. It's not yet done, but it will be done. So there's a difference. This is kind of interesting. So there's a very large difference between getting GPT to explain, to give a summary of the system. That is an opinion. It's very interesting, but it's an opinion. So it's like any opinion, you will have to go and validate it against the reality, because otherwise you're going to be basing decisions on beliefs, which seems to work for the vast majority of the software industry for a reason I don't understand. But once you'll be competing against people that are making decisions by being informed, well, it probably won't work so well afterwards. So, but I think there's a very interesting place for an AI. It's not here. It's not give me the view, but give me the code with which I produce the view. Because these two things are not the same. They look very, very similar. The first one is very appealing because, oh, I don't have any headaches. But the two things are really, really different. And that's the thing that I believe the next step would be. But AI, everybody talks about AI because it comes with this interesting proposition that it will raise productivity. It's all in the future, maybe, possibly. Different studies are showing today 10, 20%. This here actually gives you an order of magnitude on how you reason, which is the largest cost you have, without any automation. So I understand that there is a large amount of energy being invested in the marketing of those concepts, but if it is productivity gains that we're interested in, then we should probably take a more principled approach to this.
For myself, my own use of the AI is pure laziness. It's like, explain this, look up. So I was accessing Oracle Cloud, and I wanted can create me an instance in Oracle Cloud, and he produced some code, but I had an old version of the command line tools, so I had to say, look, can you rewrite that using the old version? And I didn't have to look up the documentation. So it's pure laziness on my part, really, to ask the AI to do something.
But it is fine as long as you can validate it. If you can validate it, it's perfectly fine. It doesn't matter where it comes from, as long as you can validate it. But if it just does something, if it just gives you, here it is, fine. It's very entertaining.
It put comments in the code. I wouldn't do that.
Okay, there are other questions. Alberto, you're first.
Yeah, hi. Do you have any tips for any other tool developers in other runtimes and languages as to how to make systems more moldable? Like, what are the I think you mentioned like, yeah, like the abstractions or the different tools that you would need to connect at a bare minimum to have something more moldable. I personally plan to stay in GT. I've been using 4 years, but other people that work, you know, in other languages, like how do you start getting to the direction that GT is at?
So one thing that we are showing now is that you don't, so there are two, right? One is about the tool builder and the other one is about the tool user. And you can see here, for example, in this demo, is that there's no need to know, from a tool user perspective, you don't need to know anything about the underlying implementation. So you don't need to know Smalltalk to use it for your language. If there is a tool builder around that builds it. And there are even means in which you're basically staying in your host language, even for doing the typical kind of extensions. And this is just a matter for the tool builder to support and advance. So for example, the views in this case, the more elaborate you can have those views, the better it will be. But so I think just with what exists here, you can go to a significant degree. Now, of course, people will have other kinds of preferences due to convenience and so. Well, we used to have, for example, there used to be a debate of whether or not one needs completion syntax highlighting when you have a good editor. And the answer is, yeah, well, so some people didn't feel the need for that. I don't know why, but that's what people do. So we probably won't be able to, people will make choices based on all sorts of inputs that we cannot control. My hope is that other tool builders will build environments that are more specific to whatever, and they will cater for other technologies and other kinds of preferences that we might not be aware of. But here's the blueprint. That's all we can say. Does it address the question, Alberto?
It's this one thing I had noticed, that the moldable approach does something slightly differently to way other tools are working. So for example, in PHP, their best practice for a lot of their protocols is to use immutable objects. And then the next stage in the process of, say, an object being processed by an HTTP request is to add the extra bit of information and throw the old object away. Whereas in the moldable sphere, you like to keep some state around, so you've got something to inspect. So your Ludo board had a list of moves, for example. So there seems to be a style difference that moldable introduces, which make you keep objects around that are inspectable and do talk to you, whereas other people like to throw their objects away. So
that's, again, like in the first implementation of the Ludo game, and just doing normal test-driven development, the first implementation relied on side effects, like the board state has been changed. And then we saw, well, we can't explain it. So our brain is not satisfied with those explanations. I mean, it's nice to see before and after the move, but then we said we want to see the move. So then we had to have the move. So then we said, oh, we have to have the move. They have two options. Either you have, the engine records moves, like you can replay them afterwards. For example, when you have a distributed system, you might want to do that anyway. So it's a good thing to have. Or the board does not have a state at all, and it's just a replay of moves, right? So these are the two kinds of options. So, and then of course you have to say, oh, is this feasible from a memory perspective? But today the options for handling situations like that are quite, like you have to have a very large problem for it not to be practical. So there are situations where it's actually not practical, or maybe you're going to build You're going to build a visualization only in some circumstances when you're maybe profiling or instrumenting a system for a certain thing, for a certain wire, and then you're going to throw the state away. So you're not going to keep it around. But for a good deal of practical purposes, it's not really a problem. Other questions? We're a little bit past the hour.
Well, maybe some comments also. I think it's really interesting. I like it a lot, and you have very nice visuals here. So I like visuals. So and yeah, they're very nice. So I still no. Let's put it the other way. I think what you're developing or how you develop is very much how I develop as well. So that's very much Smalltalkish programming, right? So you look at the objects, play with them, see what they can, and yeah, do things. And you have an environment which allows you to create views in a very ad hoc way. Very nice. You have a lot of standard views. And yeah, interestingly, so you have a lot of things you saved, but actually the default way is to not save anything. You're just browsing around, play around, and then it's like a conscious decision to actually keep something, right? To make it a little bit nicer and keepable and stuff like that. So yeah, that's interesting. It's very nice. But it is Smalltalk, basically. So all the features and niceties, the wonderful properties, for me, it's still Smalltalk. Add it with your beautiful visualizations. So, and then, yeah, that's pretty cool.
So,
is it a fair view? Or?
Smalltalk was important to discover this, because there would have been no other practical way for the budget we had to get this far. But being here, there's a whole range of lessons that are not Smalltalk specific and that can be implemented in other languages as well. So
what I'm sorry to butt in. I can't figure out how to raise a hand right now. But I wanted
go ahead.
Thanks. I wanted to add that it's astounding and wonderful. But as a long-time developer, I have been at all three levels of what you're able to do with this toolkit in one. From the design high-level view, requirements, and thinking about everything, the world in which the vendor or supplier or manufacturer sits, in fact. From that level to the user's day-to-day experience, and in between, where to persist all this stuff. So reflecting what has been said, this is how I develop and have developed for decades. But you've kind of embodied it in something that, from my view, as 5 years of technical writer, this is a gift. It's minimalistic. There's no work. It embodies some visualization of an end scope. It's wonderful, and it's simple enough to revisit and understand. And if you code well in Smalltalk, you're doing most of that work, and as you said, eliminating most of the reading. As for the AI, I was imagining that perhaps from something like an outline or a functional spec in old terms, AI could then implement something that we could then inspect. But this is wonderful. Yes. This is really great.
Thank you. So yeah, that's the interesting thing here is that, so if there's one thing that Glamorous Toolkit is really interested in as a case study, is the fact that you get to see we use this for every single development problem we have encountered, which is, I know, and people think, yeah, it's hard to believe or so, but it actually is like this. So there are lots and lots of little details, especially when you go into little tiny things or large things. They're all hosted in the same way. And so again, the idea was two things, right? One is, if you think about back to Smalltalk, in the 70s, it kind of showed two things. One was that there is a way to show computation, to explain computation to someone, the user interface, right? So they tested it with kids, and then kids were actually literally playing with computation. It was the first time, which is amazing, right? So they showed that it's possible to show computation, to explain computation to other people that have not built that computation. The second thing that they showed is that you can build a uniform environment, because everything is made of the same thing. List did the same out of function, object did it out of messages and objects. So, but now what we are doing is just putting those two things together. Because if the environment is the same, and you can make some of it explainable to someone, it should follow that you can make any of it explainable to someone. Because an interface is just some arbitrary level of computation. And just someone put some time into thinking about how it can be explained to someone else. That's it. So we're saying if the environment is uniform, it means it must be a way in which you can explain any part of it to someone. And that's exactly what we've been doing here. We just went through all sorts of little details and sometimes going down into something. And just given the fact that so many of you are still here, I probably didn't lose most of you. Elise.
Hi, Tudor. Good day, everyone.
Hi.
My question to you is, there was some time ago, I saw a picture of Glamorous Toolkit running on an Android tablet.
Yeah.
Have you all done anything more on that? Or could you give us some idea?
The virtual machine is available and people can play with it.
It's available where?
On the release on GitHub.
Okay, thanks.
Yeah, I think that one of the, at least in my case, presenting a small tool malleability and moldability is difficult to other developers because most of the time they are used to the, let's say, Visual Studio way of doing stuff. And having this live environment to mold and to change is kind of pretty alien to most of the developers. So in my case, I have found that people like, I don't know, data journalists or activists or other
You dropped.
So he was getting the interesting bit, wasn't it?
Yes, the interesting bit was there. Okay. Other questions until Ofrai comes back online.
As a quick filler, it's amazing seeing the progress that you've made with the environment. I mean, I guess, you showed us a few years ago and, it was kind of hobbling along and then it got better, but it was a bit slow. And I mean, seeing it today, it's slick, it's fast. I suppose it still has a few wobbles because it's doing a hell of a lot, but it really seems stable tonight, actually. Has that kind of been the experience like over the last year? Has it really kind of found its stride, I think? Is that right?
Yeah, well, so at first, the first part of the work was to see that it works. And then the fast part got later here. So
yeah, congratulations.
Yeah. But again, like getting it fast was based on the same tools, right? So the profiling tools, for example, that I showed you, literally like that one, the picture with the layout and the update and so on, was what we used to make it about more than 10 times faster within the space of 1 week. So we had this problem for like a couple of years and we didn't know how to move on with them. Because our debugger is much more elaborate than typical debuggers because it has much more information on it. Like we want to see all the code and so on. And so we didn't, and there's also laziness involved and so on. And so it was a hard problem. We didn't know how to solve. And it's almost like this is invariably the same thing. You're stuck with the problem for a long time until you figure out how would they want to describe the problem. And it's just, once you see the problem, the solution comes very, very quickly. And that's, by the way, the reason why all the focus on, oh, let's automate code writing. It's very, very fascinating to look at, but that's not the problem. Anyway, so, but yes, thank you. We wanted to take, in order for people to take us seriously, we wanted to have this one running at what people would consider reasonable speed, even if today, right, it's just using 2 processors. So we think that we can do much better on today's hardware. But so this one is very old technology, right? Just 1 processor, 2 processors. But in fact, we can actually, the Glamorous Toolkit is also a distributed system. There is in production a system that is using it to run, for example, jobs on 1,000 processors on AWS, and it's all integrated in the same environment. So you're deploying things, running things, getting the results back, inspecting them without leaving the environment at all. So this one also exists and is also in place. But still, there's a legacy, let's say, constrained architecture that comes from Smalltalk that is not necessary. So one of the things that we're looking at is what would be an interesting next step to package the same ideas.
Yeah, very cool.
All right, you're back.
Yeah, sorry.
So you were talking about, as opposed to developers, journalists, and then it stopped. So
yeah, so the issue is that I have found that most of the non-developers are more welcoming of this kind of alternative way of development. So I have like tested the Smalltalk environments with data journalists, people from social sciences, people who is not in the, let's say, traditional development way. So have you found this kind of, let's say, friction in the ideas of moldable development in the developers communities? Which are
for sure.
those friction? Yeah, the friction in embracing the ideas. And also, have you tested these ideas with other communities that are not developers? I think that, I don't know, kind of, it's kind of a, I don't know, a contradiction in a way, that the ideas of moldable development are more welcoming between non-developers. How do you struggle with this kind of friction? Have you found that?
Yeah.
And struggle with that?
Yeah, very, very interesting question. So for sure, there's a significant, it's hard for people to entertain this. We think they should, but you know, people think in very practical terms today. There's a very little principle-based, let's say, investment, or because there's so much noise. And so why should this, because we're just claiming something, but there comes something else that already claims something, and it moves them 10% further. And so it's a no-brainer, right? Well, here you might need to invest, and we don't know yet how to educate. So this is still very much an open problem. It's a very important problem. So it's not like it's their fault. It's just, it's our job to find a way to explain, and to explain and produce things that are competing with on the attention with things that are shinier and that provide shorter term kind of gratification. So that's what I think. But we do see much less resistance for students. For example, students, they don't know what they shouldn't know. So they just find it interesting, and they have much easier time to adjust to this. So, you know, like, for example, in the case of developers, we often see, you know, people consider something like code, Visual Studio Code, as being the default. And the first question is it working in Visual Studio Code? The answer is, well, no. Oh, therefore, yeah. So that's it, right? Because if this is the premise that you have, then that's the conclusion that you draw, which is perfectly fine. It's perfectly fine for an idea. It has to grow, and it has to, and by growing here is, we now know that this is a space. We know it. There's no doubt about that. And it has lots of implications. We also know that because we've seen them. I'm showing you things that are publicly available. There are other kinds of experiences that, you know, when we solve we actually have to solve concrete problems. We literally take problems for which people sometimes they've tried significant amount of money on and failed. And we can go and answer questions much faster than they could imagine. And and because of that, we know that the implications are very broad. But the realization of the environment, right, is like when people are saying, okay, sounds great, so how do I start? So the practicality of how do you start and how far that start point is from where people are right now is an important thing. And it's a whole domain in itself. Like, how do you take an idea and you package it, and then how do you teach that idea to people that are in some place? This is an important. It's absolutely an important activity. We should, and we literally we take it very, very seriously, and it's one part of the work that we want to invest energy in. Already happens, but there's going to be more. Now, on the other hand, we also think that people are very much convinced by money. So one thing that we are looking at is, or our strategy is to actually find people that want to work with us and literally make money. Because if you have something that gives you competitive advantage, you can literally transform it into money. And if people, not us making money, but them making money, and people will probably follow that kind of signal much more than anything else we can do.
Okay, thank you.
Keith.
Hi. I just wondered if you could comment on your statement about making legacy fun again, and give us an examples of how that actually pans out in practice, or can pan out.
It does, right? It's just, so the thing is the following, right? People have split systems in the thing that is old and the thing that is new. And by that, what they mean is the thing that I remember and the thing that I don't. Because either when I wasn't there, or I don't remember it anymore because it was a long time ago. So the situation of the things that people actually remember is very, very small versus what they should actually go and discover from the actual system. So we are almost always in a state of legacy. We just maybe not label it properly. So what do you do in that situation? The frustration comes when you cannot build a mental model of what the system is, and therefore your actions seem irrelevant to the system. Like, for example, we've seen people trying to optimize the system for years, only at the end the system to be exactly the same as it was 3 years before. Not for the lack of will, energy, money, all of them were spent. And at the end, there was no result. And the reason was because if your actions are not aligned with what reality is. So for example, it doesn't matter how much you're going to dance, you're not going to make rain happen. It doesn't matter how much energy you're going to put, because the mental model is just not the one that is matching reality. So, and that's exactly what happens with systems when people try to read or either rely on memory, documentation, or some other forms of getting themselves informed that are not, not comprehensive. They're not about, it's not taking the whole system in. So what's the alternative? The alternative is to treat the system as a phenomenon. As a phenomenon that you discover all the time. Every time I have a question, I'm going to think, what's the interesting experiment to do in order to answer that question? That's it.
Okay.
It just so happens that this little thing is applicable to absolutely every single problem I've ever seen for the last 15 years. It just scales.
I raised the point because we've just announced a new job opening, and it's principal engineer - heritage. And so I wondered if that might be something useful to apply. And your statement about what you understand about the system is basically understanding the heritage is going to be most of that role, I would imagine.
So, and the other thing is, like, where does joy come from? Joy comes from Because like a system, you can look at it as something that takes input and produces output. The other way to look at it is to see the computation, which is some encoding of knowledge. So when you're just looking at the system from input outputs, it's like you're poking, like the prehistoric people poking something from the outside. Oh, we did this when I did that, so let's not do this anymore. I'm going to poke it from here. So they were building a mental model, not by understanding the laws, but by understanding cause and effect, or just by accumulating causes and effects. Very, very limited, right? But then as soon as what has exploded our ability to, for example, do things was this shift from poking at things to understanding the inner laws. Right now, most people are just looking at systems from what perspective, what they do. Here's what it does. If I put this, it does this. Oh, okay. And this is how people build mental models. But there are very interesting models already in the system. So if you discover those, it's just really, really incredibly joyful. Anyway, so I've never seen a problem that is not transformable in joy. Not one. And so just as an anecdote, after I authored the original ideas that led to Moldable Development, I took a job in the worst system that I found in my area. The most horrible piece of technology. And the reason was, I said, well, if this would work, it has to work in the worst possible place. So I led the development there for 3.5 years. And during this time, I did not read almost any line of code. So it really works. And it's not complicated. Okay, other questions? Or do we call it a day? Or a night? We can call it a night.
I have more technical things.
Okay.
Yeah, not
Go
bad.
ahead.
So on one of your slides, there was namespace popping up. Are you doing anything on namespaces?
No.
Too bad. Okay, modularization, anything in that direction? Environment?
Modularization?
Yeah, like separating pieces of knowledge from each other, something like that.
You mean inside Smalltalk?
Yes, in systems.
Well,
Systems,
so
not only Smalltalk, any systems, but Smalltalk would be, of course, it's very important too.
So in terms of modularization, of course, there's interesting things that you can do on the language level, and there are interesting applications for it, like, for example, sandboxing and so on. But if the goal is...
It's important for exchanging code. It's very important for that.
Sure. No, but for exchanging... Yeah, but so if it's just modularization, for example, from an architecture perspective, a lot of it it just becomes a tool issue. So we have a significant amount of tools that are just giving us an overview. Well, in our practical terms, in our limited experience, it works reasonably well.
Things is maybe a tool question, but the problem itself has nothing to do with tools. The problem itself
is
if the language, a real problem.
Yes. So, and I'm saying that if the language does not give you modularization, you can achieve a reasonable amount of modularization, but through the tool layer. That's it. So that's what we do, and we can get to a very interesting, to very strong constraints satisfied just by doing that.
So, but there's no focused work on this kind of issues.
No, there is no focus. So not in our team.
About graphics. So graphic looks nice. Things seem to be attached. Are you working on constraint-based layout?
Are we working on constraints layout? No, not particularly at the moment, no.
And you're not using any of it? So it's all, well, made.
Yeah, at the moment, in this one, the one you've seen here, yes.
Okay.
These are just other kinds of layouts which are not constraint-based. I mean, There are constraints, but not the one that you're mentioning in terms of the class of constraint space.
Because it's rather snappy, so I thought maybe you're going that direction. So the last part is maybe a hint. Maybe you should have a look at RDF. That is super satisfying, exciting to build something to visualization. So that is a really, really interesting topic. So you're halfway there, right? GraphQL a little bit, and then this would be the throne of all of it.
We actually looked at RDF. There was one project that was focused on that. It's definitely interesting. I don't necessarily think it's anyway. So definitely an interesting thing to explore, but
no, it needs
not a current focus at the moment.
Yeah, the cool thing about that is it's self-reflective and multi-layered, folded in itself. Sure. So it's rather difficult to visualization in a general way, but cool.
Yes.
Okay. Yeah. Thank you very much. Nice work.
Thank you. Any other questions? No. Well, then, thank you very much, and see you next time.